All right, today we're in section 6.8, the counting principle. We use the counting principle to find the total number of outcomes. So when we're solving probability, we can use the counting principle, find our total number of outcomes, and then write it as probability. All right, that'll be more in example 3 than examples 1 and 2. In examples 1 and 2, it gives us two methods for finding the total number of outcomes. The first method is a tree diagram. And, I kind of debated back and forth on this. The tree diagram, the actual work that goes into producing the final answer is basically a really, really long way versus the counting principle. The counting principle works every time and you can find the total number of outcomes. So I'm actually not going to make you do tree diagrams. You can just use the counting principle. However, here's where a tree diagram is helpful. It shows you like an expanded view of all of your options. So maybe you don't just want to know a total, okay, or the final number. Maybe you actually want to see your options. That's where a tree diagram could be helpful. All right, so let's take the an eyeglasses example. All right, it says you're buying new eyeglasses and you must choose the frame material and the shape. So what you're going to see in all of these questions is categories, okay? So in this question, there are two categories, the frame material and the shape. So I have to figure out, okay, within those categories, how many options do I have? So for the frame material, it can be either plastic or metal. So how many options is that? 2. For the frame shape, it can be rectangle, oval, cat's eye, or round. So how many is that? 4. Okay, so I have 2 options of frames and 4 options on the size or the shape. So I have 8 frame options to choose from. I can multiply them together. So however many categories I have, how many options are available within each event, or maybe you could even call it an event. Basically, that's how you would solve this. And that really, in a nutshell, is the entire lesson. That's how you figure out the number of possible outcomes. How many outcomes in this scenario or in this option, how many in this option, and then you multiply them together. That's the whole lesson in a nutshell. Now we're going to take a lot of different perspectives to that, all right? But before we do that, this is the expanded version that I was telling you about, okay? So you're going to see some similarities here. You have 2 categories, just like when we set up our counting principle. There are 2 options in my first category, plastic and metal. And then it says plastic rectangular, okay, and you can follow kind of the progression over there. Plastic rectangular, plastic oval, plastic cat's eye, plastic round, and same thing with metal. And now you can see the expanded options for, your eyeglass, choices. So for some of us, we need to see those options, right? It doesn't really help us if we walk into the eye doctor place and they say, okay, there's, 125 options to choose from, and, just pick one without really seeing it or seeing the options. So that expanded version kind of helps us there. Does that make sense? Okay? So counting principle really is important. Tree diagrams show us the expanded version. All right, so moving forward, let's look at another scenario. So now we're going to use the counting principle and apply it to this scenario. You roll a blue and a red number cube. And I've had people kind of thrown off by colors and things like that. The colors don't matter. Here's what matters. How many possible outcomes are in each option, okay? So you roll a blue number cube. How many possible outcomes will come from that? We talked about number cubes yesterday. 6 possible outcomes from the blue cube. And how many possible outcomes from the red cube? 6. So there's 36 possible outcomes. Possibilities, outcomes, just something along those lines. All right, and that's it. So again, we figure out how many outcomes are in each category, multiply them together. That gives us the total number of possibilities. Why do we need to know that? It comes back to probability. In order to figure out favorable over possible, I have to know how many possible outcomes there are. And in these questions, it doesn't give it to me. I've got to figure it out. Does that make sense? All right, so now I want you to do one. Here you go. Okay, so now go ahead and read the scenario and use the counting principle to figure out the total number of outcomes. All right, so now, how many options on the yellow cube? 6. How many options on the blue cube? So how many options on the red? Okay. 216 possibilities. All right, outcomes, possibilities. I'm not going to be picky on the label as long as you have one. Okay. All right, any questions? 216. All right, now let's do one more. How many different outcomes are possible when you flip a coin and roll a number cube? All right, so how many sides to a coin? How many sides to a number cube? So 12 outcomes. All right, now on to example 3. This is really just pulling it all together. So now we're going to pull in the probability concepts that we've already learned into this whole counting principle concept. All right, so here we have a combination lock has 40 numbers on its dial. To open the lock, you must turn the dial right to the first number, left to the second number, and then right to the third number. You randomly choose 3 numbers. What is the probability that you will choose the correct combination? All right, so I have to figure out what is the total number of possible combinations here on this lock. What's the total number? Okay, so hold on though. When I turn it to the right, how many possible numbers could I land on? 40. And then when I turn it to the left, how many possible numbers can I land on? And then when I turn it back to the right, how many numbers can I land on? 40. So that kind of splits it, right? For each time I turn, so technically, could the combination be 1, 1, 1? Yeah. Or could it be 1, 2, 3? Or 2, 3, 4? Or, I mean, you could just keep going and going and going, right? 40 times 40 times 40 is what? 64,000. And how many of those 64,000?
That's wrong. It's 120. Wait.
No. 40 times 40 times 40 is 64,000.
40 times 3.
Okay, yeah. So 40 times itself 3 times because there's 40 numbers that I can land on each turn. All right, 64,000. But how many of them are the correct combination? Only one correct combination. So let me ask you this. Is it relatively certain that your valuables are safe in that locker?
Yes.
When somebody has to get the correct combination 1 out of 64,000, I'd say that it's pretty safe in there. Okay? So here's the difference between today and yesterday. Yesterday they gave you this number and they would have just said 64,000 possibilities. Today you have to figure that out. Okay, so that's going to be it for the lesson, but I do want to take some time to go over your homework with you. I'm going to go ahead and end the YouTube video so it doesn't get ridiculously long, but that's everything you need to know, at least for the lesson in 6.8.